In this video, we will learn about Numpy arrays. Now, Numpy arrays are a highly useful aspect of Python, especially in data science. You will be using it all the time. So let's talk about how to get Numpy arrays. The Numpy package is not a built-in package, so you'll have to download it. To do that, you'll have to look for command prompt, and you'll type in Python m. So you type in Python -m pip install numpy, and you'll see that I already have this requirement satisfied. I've already installed it. You will have status bars as it downloads the package. If you have Anaconda, you won't need to do that. Standard way of importing is import numpy as np, and so it's pretty standard for you to abbreviate numpy as np. So you'll see now I've imported it. Now to create a numpy array, you type in a equals np dot array, and I'm just going to put in the value of 1, and that. Okay, so the next thing is b. So now you can create one-dimensional arrays. So b equals np dot array, and you'll just insert a list. So that's a one-dimensional NP array, and we'll type in C equals, we'll do 2 brackets, so 1, 2. So this is a nested list. Now a few rules here is that whenever you're inserting this list, each one of these items have to be the same length. If this had 3 items in it, then it would throw an error. So let me just show you what that looks like. So if I were to insert maybe 11 over here, then I'm going to press enter, and it's going to give you an error saying that, well, you can't do that with Numpy arrays. So let's show you what C looks like. So what it did is it encapsulated everything into list to allow you to have a multiple size, but we don't want to do that. So I'm just going to copy this and type in C, and then you can see that I've created a Numpy array. This is the second dimension, or dimension 1. This down 1, 3, 5, 7, and 9 is along the first dimension, or the index is dimension 0 in Python. Along here is the first dimension, and this is the second dimension. And you can create 3-dimensional arrays. So I'm going to do 3 brackets, 1, 2, 4. Encapsulate that one. 5, 6, 7, 8. Like that. So the larger list has a list here, a list here, and then each one of those lists have 2 lists, 1 and 2. I'll press enter. You can see that D is a 3-dimensional array. So here is the 3rd dimension. Along here is the 2nd dimension, and then vertically is the 1st dimension. So 1 and 5 would be along the 1st dimension. Okay, so what's useful about arrays? So let's go back to C. So I want to just slice some values out of this C. So I want to pull some values out. So I can do 1 to 4, then do full colon. And what this is going to do is it's only going to pull the item 1 all the way up to item 4, so not including item 4. And it's going to include everything along the 2nd dimension. So it's going to only include these items along the 1st dimension, and it's going to include everything along the 2nd dimension. You press enter, and you can see that I've pulled 3, 5, 7, so 3, 5, 7, and then 4, 6, 8, 4, 6, 8. Another way of doing is C4, so it works a lot like a list this way. This will pull out the same thing. So You can use the 2 brackets. But it's more common with arrays to use this notation. So here's here's C again. You can do a lot of things with arrays that would be more challenging to do with lists. So I can, for instance, multiply all these values by 5. Add 2 arrays together like this, element-wise. So this is 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4. So you can see all those values are added together. So it's adding it element-wise. And you can do C greater than 4. So I want to just find out which values within this array are greater than 4. And it will return a Boolean array back to you specifying whether each item is greater than 4 or not. So I'm going to create another array, E, change some of these values here. So I just copied and pasted that original array. So let's see. So you see I've changed those values. So here's the original C, and then here's the new E. And I can say, well, is C equal to E? Or which items of C are equal to E? And it will tell you. So it'll element-wise find out if that condition is true. So any of these operations are a lot more difficult to do in lists. So for instance, the C times 5, so let's get C here, C times 5. Just to do that calculation would be challenging in a list. So let me just create a list to show you what that looks like. Okay. So there's a list right there. Now if I were to do f times 5, you can see it does not multiply each element by 5. What it does is it copies that list 5 times. So in order to multiply each element by 5 would be a lot more complicated of a process working with list, and it won't be nearly as fast either computationally. Okay, so there's a lot of ways of initializing a Numpy array variable. So I can create a 0 array. So what this is going to do is it's going to create an array of zeros that have 2 items along the first dimension and 3 items along the second dimension. So press enter, you can see there's 2 zeros here and 3 zeros along the second dimension. You can also do ones. So that's going to create a value of ones. The next thing is I can create an array of empty values. Now empty values is going to just create an array of arbitrary numbers. So, and a lot of times that's just the previous value that you've inserted. So if I type in G, it added ones because that was what it had most recent in its memories. Now, if I want to create a value of an array of nans, I could take this empty array, G, and I can specify to select all the elements of G and make them equal to NP nan. So this is not a number, nan, it's just a placeholder. So now if you look at G, there it's filled with nan values. Another very useful function is the Numpy arrange function. So H equals A or NP arrange 1 to 0.01. So what this is going to do is it's going to create, it's a lot like the range function, the built-in range function. This specifies it starts at 1, it will end at 2, and the increment will be 0.01. Press enter. So you can see it's created an array with where the increment is 0.01. So this has a lot more capabilities than the range function. The range function is faster in many respects, but the arange function will give you these decimal values that the range function won't. Okay, so let's get back to C. Now we can also change values within this array if they meet a certain condition. So you could type in, the function you use is where. So you do np where. So we're going to do c greater than 4. So let's find all the values that are greater than 4 and replace them with 20. So I have the condition, the value I want to change it to, and the array I want to do the changing. So you can see it replaced all those values with 20. Now you can also see if a condition is met across an entire array. So for instance, so c greater than 20 checks, or c less than 20, c greater than 4 is checks to see if each element meets that condition, but you might want to check if all the values of c less than 20. So you can do np all, and then the condition c less than, let's do less than 4, and it's going to return back false because in this array there are 3 values that are less than 4, so that's going to be false. You can do np all c less than 20, and that is going to be true because all those values are less than 20. You can also go along a specific dimension, so you can do np all c less than 4, or let's do less than 10, and then we're going to go along the first dimension, and that's going to return back an array that tests whether along this column are all the values less than 10, and that would be true. And then along the second column are all these values less than 10, and that would be false. And you can of course do it along the other dimension. C less than, let's do 9. We're going to go along the first dimension, or along dimension 1. So that would be along this way. And so you can say this is true, it's less than 9, this is true, less than 9, this is true, less than 9, and this is the condition where they're not less than 9. The next thing is maximum. You can do np max c, and it's going to return back to you the maximum value of c, which is 10. Now we can create another array. Let me pull up B. So B is a small array, 1, 2, 3, 4, and I'm going to create another array, G equals np.array. I'm going to do 0, 5, 3, 4. Okay, so there's G. And now I can I can pull out the maximum value of each of these two arrays. So if I were to do np.fmax, and I'm going to do B and G, it's going to pull the maximum value of each of these at that specific position. So it pulls 1 because that's the maximum of 0 and 1. It's going to pull 5 because that's the maximum of 2 and 5. It's going to pull 3 because they're the same. It's going to pull 4. So this, you can pull only the maximum of each array. So that's very useful. So that's a very quick way of doing that. So Numpy arrays are useful for working with very large data structures where you don't want to use some complicated code that you would need for lists to iterate through the entire list to do a single calculation. And so Numpys are fast. You can replace all the values with 20, or you can replace an entire column with a certain value, or you can multiply an entire array by a single number. Whereas in a list, you'd have to iterate through each item.